Let's take a look at first question. Now, use the minimum number of turns to form the number 2010. So make use of the turn, we can get 1000. To get 1000, you just do 10 times 10 times 10. Now, there's also a way to make 2000. We can do 20 times 10 times 10. So 20 will just be 10 plus 10. So get 10 plus 10, which is 20 times 10 times 10. That gives us 2000. So plus 10 equal to 2010. So the least number we are going to use is 5. The answer is B. Question 2. Now, when the upper hand and the mini hand, when they form a straight line, there are two cases. It can be 0 degrees, where they overlap with each other, or it can be 180 degrees. Right, let's check the 0 degree first. This is when they overlap with each other. So first time is after 1 o'clock. So I'll just write 1 plus. After 1 o'clock, both upper hand and mini hand is pointing between 1 and 2. It's the first time they overlap with each other. So next time is after 2 o'clock, both of them pointing between 2 and 3. 2 plus, then 3 plus, 4 plus, 5 plus, 6 plus, 7 plus, 8 plus, 9 plus, 10 plus. Now, for the last one, 11 plus, they happen exactly at 12 o'clock. Okay, so the last one is 12. So altogether, there's 11 times in 12 hours. Now the time given is from 1 o'clock to 1 o'clock on the next day. So that's 24 hours time. That means we need to times 2. So 11 times 2. 22 times when they form a 0 degree angle. And when they form a 180 degree angle, that is after each overlap. Okay, after each overlap, there's one time they form a 180 degree angle. So you see at this instance, it was 0 degree. They overlap with each other. Then after that, somewhere in between, they'll form a 180 degree angle before it becomes a 0 degree again. So after each of the overlap, they will form a 180 degree angle. The 22 times they overlap with each other. So this will be 22 times they form 180 degree angle. So altogether, we have 22 times 2 equals to 44. So the answer is D. Now, for question 3, we factorize the number m times n is 2010. So there's 2 times 5 times 3 times 67. Okay, there are 4 different prime factors. Then we can find the total number of factors. Alright, each of the index number plus 1 times together. So we have 2 times 2 times 2 times 2. Okay, this equals to 16. There are 16 factors for the number 2010. 16 factors means we can separate them into 8 pairs. 16 divided by 2. There are 8 pairs of number. But for each pair of number, so for the first pair is 1 and 2010. Now, if we reverse the order, these two are considered different. Okay? So for these 8 pairs, each of them have 2 different arrangements. Two arrangements for each pair, so 2 times 8. In total, we have 16 different arrangements. So the answer is D. Question 4. So digit sum of the number equals to 3. And we want to find the next 3 numbers after 2100 that give us the same digit sum. Now after 2100, the next one that give us the digit sum of 3 will be 3000. After that, it cannot be 4-digit number. It has to be a 5-digit number. So if it's a 5-digit, we like the front digit to be as small as possible, which is 1. So 1, 0, 0, 0, 2. After that, next number, so 1, 0, 0. Now, be careful. This is not 1, 0, 0, 2, 0. That's not the next number. So before that, we have 1, 0, 0, 1, 1. This is smaller. So we add them together. 2, 3, 0, 1, 3. So the answer is E. Now, question 5. We can see the numerator is 1 less than the denominator. Difference is always 1. So let's compare it to the whole number 1. First one is 1 minus 1 over 2. Then 3 over 4, this is 1 minus 1 over 4. 7 over 8, there's 1 minus 1 over 8. So all the way to 1 minus 1 over 256. Right, let's group them together. So first we take out the whole number. We can see there is a total of 8 groups here. So this 1 times 8. Minus the sum of these fractions. We group the fractions together. So 1 over 2 plus 1 over 4 plus 1 over 8 all the way to 1 over 256. Now, the sum of these fractions, there's a pattern. If you do 1 over 2 plus 1 over 4, it's equal to 3 over 4. Then if you do 1 over 2 plus 1 over 4 plus 1 over 8, this equals to 7 over 8. Right? So you see the numerator is always 1 less than the denominator. So if you add all the way to 1 over 256, you get 255 over 256. Right, so we get the final answer, 7, 1 over 256. We choose option C. Okay. Question 6. Find area of the sheet region. Now let's connect radius of the circle. So we can move part of the sheet region, move this part to fill in the gap. So this way the new figure is a sector. This is a sector of the circle. Now when you look for the angle, this angle will be 60 degrees. Because you can just connect the other line here. And this will be, okay, let's label it. So you'll get that BA equal to BC. And those are the radius of the circle B. Now, if you choose a different circle, let's say you choose the circle A, BA and AC, they are also the radius. So AB also equals to AC. Okay, it's the radius of the other circle. Since the circles that are all identical, so the radius are the same. So we find that the triangle ABC is equilateral triangle. Then the angle at the center is 60 degrees. Right. So for the shadow region, it's a sector. This is 60 over 360. It's 1/6 of the circle. Now let's start in the value. 1/6 times pi times the radius squared. Radius is 2, so times 2 times 2. This equals to 44 over 21. Change it into mixed number is 2, 2 over 2 over 21. So the answer is C. Now let's move on to question 7. These are consecutive odd numbers. They want to find the number of digits. So the one digit goes from 1 to 9. The 5 numbers, so 5 times 1, 5 digits. Now 2 digit from 11 to 99. So we find the number of terms. That's 99 minus 11 divided by 2 plus 1. The 45 numbers. And since each number contains 2 digits, so the number of digits is 45 times 2. That's 90 digits. Next, for the 3-digit number, so we start from 101. Let's find how many digits are left. So we use the total 1000 minus 5 for the 1 digit minus 90 for the 2 digits. The 905 digits left. So since each number contains 3 digits, divided by 3 equals to 301, remainder 2. So there are 301 3-digit numbers. Now for the 1 digit and 2 digit, we have 99 numbers. So altogether, that's 99 plus 301. We got 400 numbers. Okay, so 400 odd numbers. Let's find the last odd number here. Wait, let's change it. This is not 99 because we only had odd numbers. Okay, so 1 digit is 5. Okay, let's change it. And the 2 digit is 45 odd numbers. So it's plus 5 plus 45. 351 odd numbers. So we can get the last number. The last number will be 2 times 351 minus 1. That's 701. Okay. So the first odd number is 2 times 1 minus 1 equals to 1. Second odd number, 2 times 2 minus 1 equal to 3. Third odd number, 2 times 3 minus 1 equal to 5. Okay. So it's all the way until 351 odd numbers. So it's 701. So now if we list down these numbers, we got 1, 3, 5, 7, 9, all the way to 701. And we have a remainder of 2. So these are the next 2 digits from the number 703. The digit is 0. So the answer is E. Now, question 8. Aaron answered half of the question correct. Bob answered 1/3 correctly. Charles answered 1/4. Dean answered 1/5. So you get LCM of 2, 3, 4, 5. LCM will be 60. Okay, we had to find a number that's divisible by 2, 3, 4, and 5 at the same time. Okay, so we let the total number of questions be 60. Then we find the number of questions answered by these students. First students, Aaron is 60 times half plus another 7 questions, so 37 questions in total. For Bob, this is 1/3, so 60 times 1/3 plus another 17 questions equals to 37. Charles answered 1/4 correct, so 60 times 1/4 plus another 22 questions also equals to 37. Now for Dean, this is 60 times 1/5 times 1/5 plus another 25 questions equals to 37. So now we realize that all 4 of them answer the same number of questions correctly. They're asking which people got the most questions correct. So the answer is E. They are all the same. Now, question 9. Find the last digit. So let's separate them into groups of 10. Okay, every 10 numbers is one group, except for the first group. First group is from 2008 to 2001. And then for the other groups, it will be 10 numbers in a group. So 2000 to 1991, and then 1990 to 1981. So all the way to 10 to 1. 10 numbers in a group. Okay. So let's find the last digit. Now, for simplicity, because the last digit for each group is the same, let's just check the last group. It's from 10 cube to 1 cube. So 10 cube minus 9 cube plus 8 cube minus 7 cube plus 6 cube minus 5 cube plus 4 cube minus 3 cube plus 2 cube minus 1 cube. Okay, let's look for the last digit. The first one, 10 cube, ending with the 0. Now 9 cube, 9 times 9 is ending with 1. The 1 times 9 ending with 9 again. The last digit is a 9. Then 8 times 8 is 64. 4 times 8, 32. This ending with a 2. 7 cube, 7 times 7 is 49. 9 times 7, 63. Last digit is a 3. So 6 cube ending with a 6. 5 cube ending with 5. 4 cube, 64 ending with a 4. 3 cube is 27, and then with the 7, 2 cube is 8, 1 cube is 1. So from there you get that the last digit is 5. And for the other group that's not complete, this one is from 8 cube all the way to 1 cube. So again, you look for the last digit where you can just copy down from here. 2 minus 3 plus 6 minus 5 plus 4 minus 7 plus 8 minus 1. We find that the last digit is 4. So let's group these numbers together. 2008 divided by 10. Now 200 groups with the remainder of 8. Now for the first 200 groups, the last digit is 5. So we got 200 times 5. Then for the remainder 8, these 8 numbers, which is from 2008 to 2001, the last digit is 4. So plus 4 equals to 1004. So the last digit is 4. The answer is 8. Now let's move on to question 9. To find the sum of angles here, we can use the formula 180 degrees times the number of corners minus 360 degrees times the number of intersection points. Right, so A, B, C, D, E, F, G, that's 7 corners here. So it's 180 times 7. Now, for number of intersection points, this part is that you choose a point at the center, connect this to any of the vertices here. Let's say you connect it to A. So check how many intersection points are there. There's 1 and 2. There are 2 intersection points. Now, if you connect it to any of the other points, number of intersection points will be the same. Let's say you connect it to F. So we also get 2 intersection points. 1, 2. Okay, so you get same number of intersection points. Each time you get 2. So it's 360 times 2. So we get 1260 minus 720. The answer is 540. So we choose option E.